Hi y'all. Today we're going to be looking at graphing in quadratic inequality from standard form. So what you're used to seeing is vertex form. That's what we did yesterday. And it was already given to you, your h and your k, just by looking at the vertex form. Now you're given standard form already. So I've got y on one side and I've got everything else on the other side. And I need to find my vertex from there to help me plot. So I wrote out the steps. We're first going to factor, then you're going to solve using your factors by setting them equal to 0. We're going to plot our solutions on the graph. We're going to plot the vertex on the graph, and then we're going to use a test point to shade. The first thing I want to do in order to get my factored form, I have this negative sign around my x squared here. I don't want that there anymore. I want to make it positive so I can easily factor. So I'm going to divide both sides of my inequality by -1. Whenever I divide by a negative number, I have to flip my sign. Negative x squared divided by -1 gives me a positive x squared. Negative 4x divided by -1 gives me positive 4x. And positive 5 divided by -1 gives me -5. So now I can identify my a is 1, my b is 4, and my c is -5. And I'll do an I, for those of you that like the I. AC is at the top, B is on the bottom. A times C gives me -5, and my B is 4. I need two numbers that are going to multiply to give me -5 and add to give me 4. So I need 5 and 1. And I know that one of those numbers has to be negative in order to give me -5, so that's going to be my -1. 5 minus 1 gives me 4. 5 times -1 gives me -5. I have an a value of 1, so I don't have to do my grouping. I can just say that these two numbers are my factors. So my factored form is x plus 5 times x minus 1. Okay, I still need to solve it, so I'm going to change my inequality sign to an equal sign. And in order to graph, I need to find my x-intercepts. My x-intercepts is the point where the curve is going to go through the x-axis. At that point, y is equal to 0, which means that I'm going to set y equal to 0. Now, I can break this up and set both of my factors equal to 0 to help me solve. So I get x is -5, and I get x is +1. So my x-intercepts, remember I said that's the point when y is equal to 0. So if I want to write these as coordinate points, I'm going to have -5, 0, and 1, 0. Go ahead and plot those. Got -5, 1, 2, 3, 4, 5, 0. So about here. And I've got 1, 0. So here. Those are my x-intercepts. After I get my x-intercepts, I want to go ahead and find my vertex. So we're going to need to use our A, our B, and our C that we found earlier. Your vertex, if you're given standard form, so your h is -b divided by 2a. That's the h coordinate for your vertex. So our -b over 2a in this case is -4 over 2 times 1, which just gives me -2. If I want to find the k, I have to evaluate my standard form with my -2 substituted in. So I'm going to take my original equation. So I had x squared plus 4x minus 5, inequality. All that is greater than y. I just flipped my sign. And I'm going to replace wherever I see an x, I'm going to replace that with my vertex h value, which is negative 2. So I'm going to have negative 2 squared plus 4 times negative 2 minus 5 is greater than y. Do your PEMDAS. You've got negative 2 squared, so you got 4. 4 times negative 2 gives you negative 8. Minus 5 is greater than y. This is going to give me negative 9 is greater than y. So your k value is your negative 9. So your vertex h comma k is going to be at negative 2, negative 9. Go ahead and plot your vertex negative 2, negative 9. About here. Okay. And my a value is a positive. So I'm going to be opening upwards, and I have to open upwards in order to connect with my other 2 points as well. So I'm going to look something like this. Now I have to use my test point to figure out my shading. So we can pick a test point anywhere inside of the parabola. I'm going to pick 0, 0 because it's super easy to use. And I'm going to substitute it into my original inequality and see if it gives me a true statement or a false statement. So I've rewritten my original inequality, and I'm going to substitute in 0, 0. So I've got 0 is greater than, this is 0, this is 0, so I'm only left with 5. 0 is greater than 5, that is a false statement. So when I shade, I am going to shade on the outside of my parabola. If you were asked to pick 2 points from your solution set, again, you can pick any 2 points that are in the shaded area. So I can pick 1, 2, let's pick 3, 3, 1. I can also pick 5, negative 2. Both of those points are going to be in our solution set. For example 2, we're going to do it a different way, but it's still going to work out the same. We're still going to get the same vertex and the same points along the parabola. So I'm going to find my vertex. My vertex is going to come from that same HK, where my H is negative B over 2A, and then we can find K by putting in the H value into the original equation. So my A value here is negative 1, my B value is negative 2, and my C value is 8. So finding my H, it's negative B over 2A. So I've got negative on the outside. Then I've got a negative 2 as my B value. 2 times A is 2 times negative 1. So I've got a negative times a negative 2 gives me a positive 2. 2 times negative 1 gives me negative 2. And this reduces down to negative 1. If I want to find my K value, I'm going to put negative 1 back into my, I'll say equation right now, but we're going to use the inequality sign for shading purposes. So I've got y equals negative times negative 1 squared minus 2 times negative 1 plus 8. Don't forget your parentheses when you're substituting. So this gives me negative 1 plus 2 plus 8. So 8 plus 2 is going to give you 10, minus 1 is going to give you 9. So my HK, or my vertex, is going to be at negative 1, 9. So you can go ahead and plot that, negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my vertex is here. I can still use the trick that you used before, treating your A value kind of like your slope. So your A is negative 1. So I can move down 1, right 1, down 1, left 1, and draw my parabola. Just like that, okay? I think that this way is a little bit easier than having to factor and find your x-intercepts and then go from there. But either method that you want to use will work. So I need to find my shading now, so I'm going to do test points. So test point I want to pick, I'm going to pick 0, 0. 0, 0 is inside the parabola. So I'm going to substitute 0, 0 back into, now I'm going to use the inequality, because the inequality is what tells us the shading. So 0 is greater than this. Again, make sure you watch your parentheses when you substitute. This becomes 0, this becomes 0, so I've got 8. So this is saying 0 is greater than 8. That's a false statement. So I'm shading on the outside of my parabola. Some things in the solution set. You can pick any point that you want from outside the parabola, so in the shaded region in this case. So I can pick 1, 2, 3, let's say 4, 2. That's in our solution set, okay? So at this point, I've done 2 examples, one of each type, so I've done it 2 different ways. I want you now to go try at least 2 on your own. These are the 2 examples that I want you to try. We're going to look over them quickly before the quiz on Friday when I get back. And if y'all have any questions, you can come by in the morning on Friday, and we're going to do the little review before the quiz. So y'all try these. Have a good day, and I will see you on Friday.